Every once in a while, I get in a room where I recognize people and know them wrong. Are you going to take this?
Maximum try to see what is very new.
Yeah.
I just want to know what it was.
So hello everybody, let's start. I think we're already 5 minutes in, so let's really start now. Welcome to the RMCAT session. My name is Mia Kühlewind and this is Carol Nielsen sitting next to me. We will have 2 sessions this week. One is today and one is on Friday, but I will tell you more later. First of all, I will show you the short version of the note well. So the note well applies. You should already have seen this by now, and you should probably already know what's written in there. Otherwise, if not, and this is too quick for you, go on the web page and search for it. Yeah, you might already know our mailing list and all this information here. There's also for the remote participants, we actually have a virtual queue and meet echo, so we try to maintain this. So like the remote participants, we have some, yeah, can join the virtual queue, and we will try to put them on the mic So I hope that works well. Okay, and then we start right over with the document status. So this is all the working group documents we have. So we have a bunch of them here. We have one document which is actually finished. It's in the editor queue and it's waiting for some other documents of some other working groups to be finished. So that's sitting there for a while, but that's okay. No actions needed here. Then we have the evaluation criteria. We just have seen an update on this. And I think so a lot of the open issues have been resolved, but there are a few left. We should see some slides on these. But there was a request to find maybe another co-editor here for further requests on this document, but we can discuss this in the next slide. Then we have a rather new document that's the codec and interactions, or congestion control codec interactions document. This is a not too long document. It has a lot of descriptive text at the beginning, what the idea is, but then the actual interface interactions are rather short. So we think this is already in a very good shape, and we would like to assign reviewers here. So we will take names at some point, but I'll go on with the list first here. Then we have the test cases. So this is the basic test case. These are also in very good shape. I think like all the candidates have used those test cases. There have not been much changes over, I guess, like the last 2 meetings. So this is basically also ready. At some point we discussed that we want to wait with all of these documents until the candidates are ready to submit. But like the candidates are very close to a working group last call or to a first submission. And so we could think about moving the test cases forward here. And again, the test cases have been read by a lot of people because they've implemented it, but we have not seen a lot of feedback on the mailing list, or we have not seen a lot of detailed reviews on the mailing list. So again, we're looking for reviewers here on the next slide. No. And then we have the wireless test cases, which is also a rather new document. And we have also so that's our working group document on test case and wireless test cases. And we also have a draft on Wi-Fi test cases, and like the authors of those 2 documents have now agreed to merge the 2 documents, and that's coming up. And like, Sahid, are you ready to submit something this week? He's not even listening to me. Are you ready to submit something this week, or when will you submit the merged document?
Jahid Eriksson. Yes, we're planning to submit this week. I mean, I have got input from the Wi-Fi authors, so there is merging. We have already merged them, the changes they have proposed, and now we're reviewing it. The authors are reviewing it, and then if it's more about alignment. Like, I mean, there are 2 different drafts. We put them together, kind of align,
yeah,
so that it doesn't make so much confusion. So that's what we are currently doing, and I'm hopeful like we can submit it this week.
Okay, so if you submit before Friday and there's anything you want to discuss in the Friday session, that's possible, just to let you know.
Okay. Yeah. But I think we already have slides discussing that one. But
okay,
I mean, if people have some comments, if they put up something like quickly in the mailing list, then we can obviously discuss those things on Friday.
Thank you.
Yeah.
Then the candidates, we have adopted since the last meeting 2 new documents here. So that's the Google congestion control and the CAPI congestion control as working group documents. So those documents have been around for quite a while, and we've seen good progress and updates on all of the documents. So basically the status here is as well that review is needed, but there has been a lot of progress, and we will discuss this on Friday actually. And then we have 1 expired working group document, but I think the group is at the moment not clear what to do with the working group document, so we just wait here. Okay, then we have a few additional documents. So that's the good news. We have a lot of working documents, but not a lot of other documents left. Yeah, I think the only one that is worth mentioning is like the Wi-Fi test case will be merged with the working group document, and then we will have a presentation on the congestion control extensions later today. Right, the FEC.
No, actually, I had a different question. Varun Singh. So what's holding up the traffic source? Because I was under the impression that this was already a working group document. or should have been?
So we did not see an updates in the last meeting.
Okay.
And we did not request from the authors to ask for working group adoption. But we can discuss this actually.
Because I think there are two mechanisms there, and we see an open source for one of them, and the second one we've already shown to work. So like,
but we'll have a presentation on this on Friday, and I think actually the intent was to have an adoption call be made on Friday. I mean, I actually wasn't the same impression that you, that perhaps we had adopted it, but I went back and checked the menus from the last one, and we haven't adopted it. So, but that's the plan for Friday.
Jahed, on the same topic, I mean, we discussed about adopting it last time, but we said like we need another review. So I hope the main author Xiaoxing will update this. We have some update, and then perhaps we can go for adoption.
So there's nothing particular that's holding this up.
Actually, since you mentioned FEC, so I'm back. I don't know how to proceed with it, I think. So the question, I think last time was it, is it still a generic mechanism that people feel they want to do it as a generic thing, or do they want to, like, should we explore it as an independent mechanism? So
have you taken any steps forward in getting this implemented somewhere?
I can't point fingers right now, but I will chase after people because I don't want to name call. So
I think that's what you should do right now, yeah. And like we as chairs, we have like too much other stuff on the agenda that we will, like, it's your responsibility at that point. Okay, now we go to the next slide. Right. Maroon, we are waiting for a document from you. The last one, yeah.
Stefan and I agreed that we will put something together this week and maybe have something out soon.
Hopefully.
Friday.
Perfect.
And you can stay up. So we have the slides on the evaluation criteria. So if you could just briefly go to the status.
Yeah, so this document needed a bit of an update since, where was the last meeting before Prague? Dallas, yeah. And there was some feedback from the chairs and other people that there was some overlap with the requirements, which is now gone. And the reason I made it like disappear entirely because the group has made like a lot of progress since then on several states. And the main thing was like simulating video and the wireless test case, which had a lot of like ambiguous text in this document. And it became very easy to punt that discussion to the existing drafts that we have now and basically say that this is now done there. And we have now individual sections which talk about like where to go look for this information. So that was perhaps the major change that happened between 04 and 03. There's a link that people can go and look at it. Next slide, I think. There was the like agreement to use a short TCP model as discussed in Prague, which was also on chair slides before in Prague. So I basically made that coherent and I put it in, chose values that from the October. So in the Prague model that was based in July, I just used numbers from the current month that I saw that were relevant for that case. And I think there are two small things waiting, metrics, and we've always said that we'll add more metrics as people see fit. So I don't see that has changed yet, as in I've not received any feedback on adding new metrics, but I believe that as we move forward, this would become more useful. And there was a proposal by Google in the last meeting to use a different jitter model, and I think it's an amicable way forward to add it to the mix. And if and when we have more discussion on it, if we decide that we only want one jitter model, then we can have that discussion then. But for now, the idea is to add both, like we have an existing jitter model and add one more from that jitter that Google described last time. And I'm working with Stefan on adding this. And so that's the only minor update that's waiting. So that's the only open issue right now.
One quick question. I think we discussed this already, but we were not sure what the outcome was. Because you mentioned the video model in the document, and then you just refer to the other document, and the intention here is to keep those two documents separate, right, and not merge them into one document.
I'm open to this, as in I'm not sure what. I think the other document's long enough that it can stay separate, and this one can just point to it. I think that's reasonable way forward.
So I think length alone should not be the only criteria, but I have the feeling that the other document has a value as a standalone document because it might be valuable in a different context as well.
True. So that's why I said like it's fine to like keep it separate and just pointing to. The only thing that we could probably make a more stronger statement is that there are two models. Which one do we prefer, or they're both okay, or under what circumstances, which of those are useful? Maybe we want to make a categorical statement in the RMCAT eval criteria. So, and the document itself can say what it prefers individually, but maybe if that is the way forward. So.
That sounds good. And there was also a question about should we specify which video, like for the trace-based model, should we specify which video sequences should be used, and where should this be specified?
I think we can now move it out of the. It's in the eval test. I think we should move it out from there, because if the wireless test is going to sit independently, then the sources can be moved into this document and we can say, here are a bunch of sources that we could use, and then say something normatively saying that if you had to pick one, then pick one, this one. And that would be like my impression. So yeah, so there's one minor, another update missing then apart from the jitter and the metrics, then make a more normative case for video sequences.
Jahid. So the video sequences, I mean, that needs a separate discussion, I guess. So so select what are the video sequences we should really use and where to put them. I think eval criteria is a good place to put them.
Okay, that's all I want to know for now. The other discussion we can have on Friday.
Yeah, because we need to decide like what are the things. And yeah, I was about to say something else.
Actually, the discussion's valid, but I think moving that part of text which already exists in another IETF document to this document should not be controversial. So moving it should be easy, and then making it an open issue here would be easier to like keep track of it, because I definitely lost the point when I was making those edits.
And again, I mean, the current text just says like we're talking about head and shoulder movement. I mean, this kind of thing. I mean, so moving that text is not a problem. But if you want to say like, okay, this is the set of video sequences that we would like to use when we are creating trace or doing emulations or something like that, then basically we need to discuss like what should it be. So that's what I meant.
Okay. Just a pointer. So Varun Singh again. There is another working group called NetVC, which is tackling a similar problem, because they're defining a new codec and they have the same thing, like they need raw sequences for this. And I think maybe we just need to like figure out as a joint activity or something, like like if they prefer something, then we should just inherit from there. Or so no, it's here. It's NetVC. It's currently in conflict with this one.
But it sounds as if you know what you want to do with this document, and also that the document needs to be held open. I mean, at least one or two IETFs more while things progress. But you have also, do you need for somebody else to step in and support you, or do you have those persons already?
I don't have a person in mind, but I wouldn't like if someone wants to has the cycles and is willing to put forth the effort, I would generally welcome it. And someone who's already editing the other documents might be easier to do that, but well, like, I'm open to whoever steps forward. But if no one steps forward, it's I think we now have it under control. So like there are minor updates. And
so is there any more contribution by Stefan needed, or do you already have everything you need?
Stefan, what do you mean?
Yeah, the jitter model, for example, and no, the TCP model was input from somewhere else, right?
So
Okay, so the jitter model is already everything in there, and you're
No.
happy with it, or you would like to contribute here?
yeah, we will add the jitter model that we used
Okay.
in our simulations.
Would you also like to be an editor on this document and maybe have some cycles to care a little bit about it?
Yeah, that probably works.
Okay, very cool. Thank you. Okay, then we have the usual slide with our milestones. So we have one new milestone which we finished, which is adopting the coupled congestion control, as well as the shared bottleneck detection, which was already adopted a while ago. However, as you can see, there are a bunch of milestones coming up very soon. We might not make them, but actually we hope that we make a lot of them until the next meeting, which would be then March next year. So we're keeping those deadlines for now and trying to do our best here. I mean, that's our intention. I hope you, the authors, can agree to this. But it's our milestones, right? And then there's one minor change we did on the milestones is this milestone which says that the identifying and controlling groups of flows should be, so it previously says it should be standards track, and we talked with the authors of those documents and they want to keep it experimental, and so we changed the milestone here, just to make you aware of that.
Yeah, so just to emphasize, I mean, we have milestones here that, and in order for us to meet them or meet them before the next IETF, that would mean that we would need to have reviews of the document, and possibly, I mean, we are open to having some of the documents go through work group last call if it's possible, or at least we think it would be good, given the status of the document, that we try to wrap them up or try to put some pressure on having them at least be substantially improved before the next IETF. So we think that we had, as Mia mentioned earlier, we have now the document on the interactions in between the congestion control and the codex. And we think that it could be good to say, well, let's have a review of that and let's try to commit to a date where we have these reviews in, so that we have a possibility to at least have reviews and discussions before the next IETF. We've also had, I mean, our goal for this document is to provide it to the RTC web for comments, and so it would be really good if we could, after this review process, send it to the RTC web. So, and then, I mean, one proposal would be to say, well, in January, the second one of these deadlines, and then we would very much like for people from the congestion control algorithms to make a review of this document. So we were looking to have names, preferably one from each solution, commit to make a review of this document, and also commit to it, possibly this date. I don't know what you think about it. So basically, we're asking for Scream, NADA, and DCC authors to say whether they would commit to make a review of this document within one of these proposed dates. So you would. And should I say January 22nd or January 29th? Do you have any preference, or we'll take the 29th? Yeah, we'll take the change. So that was Stefan. What about, would you do a review from the Screen perspective, Said?
I think I am an author of that draft.
Yeah.
Yeah, but I will ask Ingemar to do that.
Okay, that's.
Or yeah, I'll ask Ingemar to do that.
That's good.
Maybe I think if I'm allowed, I think Boo Burman is Boo. Can you? Yeah. So Boo Burman will review that.
Okay, so we'll put some.
And now I'm going to wake up Michael Ramallo. You want to put your name in for reviews? For those, we need reviews for those two documents. And I think you're not an author on those documents, right? Okay, which? So yeah. Codec interactions. No, yeah, we want to review it until the 29th of January.
The perspective of your review is to review it from another perspective as well, to see if it complies with what NADA would provide as an interface. And then we basically have the same question for the evaluation test cases for the base one.
I think also the couple congestion control use those test cases, right? So you can review. Yeah. And Stefan again? Yeah, perfect. And somebody else, I mean, like, even if you don't have a candidate algorithm, you can review this document if you want to, right? Okay, but that's fine for now, right?
Yeah, and we've said that the evaluation criteria document would stay open. I think we'll see whether this evaluation test case, whether it can actually be wrapped up now, or whether we will also keep it open. But let's have the review first, and then we decide on that.
Okay, that's our agenda for today. We have 3 presentations. The first one will be on the evaluation test cases, both on the wireless as well as basic test cases. Then we have this congestion control extension presented by Stefan, and then we have the shared bottleneck detection update here from David. If you have, like, we used to have a slot here for the video traffic model, but Xiaoqing is unfortunately still in her plane on the way here, so she will present this on Friday. And then I also quickly show you the agenda for Friday. So that's now the video traffic model, and then all the candidates provide an update here, including coupled congestion control. If you have any comments on the agenda, go to the mic now. Otherwise,
Colin Perkins, so no comments on the agenda, but please update your list of conflicting working groups before the next meeting.
yes, so I mean, that's NetVC, right? Is there any other conflict?
PERC, PERC, which does privacy.
Sorry for that. Okay, then we go into our first presentation, and that's Sahid, right? Yes. Yep. Take the window and then go into full screen mode.
Okay, so my name is Jahida John Sharkar, and I'm going to present the updates on RMCAT test cases, and that means I will both cover the basic test cases, the eval test case, O2, and the wireless test cases, 1. So next slide. And it's supposed to be Xiaosheng actually made most of the slides, so she was supposed to present, but she was not here. She's not here now, so I'm presenting. So 2 major changes that we did on the eval test case 02. One is we decided we used to have a fixed value for the path capacity. So if we change, we said like 1 megabit to 2.5 megabit, then 800 kilobit per second and 1 megabit. So that's the fixed values. But then we also discussed that people might want to use bigger path capacity. So how do you then define a test case that's kind of generic, and they give you the flexibility that you can change it? And how, so then the solution was like, okay, we make a reference bottleneck, then we describe in terms of that one. So the reference bottleneck is like, if you say it's 1 megabit, then you define that path capacity variation is like 2x, or I mean, as a ratio. So whatever the initial path capacity or reference path capacity that you select, you modify the rest of the variance depending on that one. So that we included. And the next and changes was like the way we vary the path capacity. So there was discussions, and there was a suggestion from Giorgio Mena saying like, well, what about so from beginning we said like the path capacity variation, we changed the capacity of the path. But he said, what about adding like background traffic? I mean, you actually you maintain the path capacity, the capacity you want for the RMCAT flows, and then you introduce more background traffic. So you have a fixed physical capacity, path capacity, and then you shuffle around these values between background traffic and foreground traffic, and then in the foreground traffic is the RMCAT flows. So that's what we did. And then we also, just to let you know, we also updated some references. The reference list doesn't include, I mean, it used to refer to wrong versions of documents, so we changed that one.
Yeah, one thing. I had a question. Is there like, did we agree on how this packets would be generated for the UDP traffic? Like, what is the rate, packet rate? What is the packet size? What is there discussion needed on those values, or are we happy with the ones that we picked? Because I think
now it doesn't really define anything like that.
Right.
So the question is more like, do we need to specify? I mean, does it really change the dynamics of the test results? I don't know.
Yeah, I would imagine like if you were to generate 500 kilobits per second, you would concern yourself with how that 500 kilobits per second was generated. Like, was it 50 packets, 5 packets, 100 packets? So I would definitely be interested in like if that has been. I know there is some text there which suggests to how to do this, but I'm not sure if that is in any way consensus or like agreement on how we want to do that.
I don't think we even have discussed this before. So what I was asking from very beginning, so what is basically the benefits and how do you really do that? I mean, I had some email conversation, on the list. You might have seen that, but I don't think like we have discussed those in particular. Like how do you generate UDP traffic? It just says, now the draft says you generate constant bitrate UDP traffic. And that basically, I think in current settings, the initial values, the reference values we have, then basically you have a 4 megabyte link, and then for 1 megabit of RTP RMCAT flows, you generate 3 megabit of UDP constant bitrate traffic. How do you generate? That's not.
Because I think one of the feedback was that we have to measure this impact on that traffic, and I think the impact, like if you choose a different packetization interval or something, then you would see a different kind of behavior, or like the measurement would actually be different, the impact would be different. So
yeah, so I can personally say, like, I have not tried out that with this environment setup. So only results I have seen using those data is from the NADA results. So Xiaoxing has put some figures there, so you can look into those one. But let's go to the next slide. So I already discussed this in the mailing list, but here for your reason, I think the main thing was like, well, you have a constant bitrate packet size, and then you change the path capacity, so you actually make the queuing delays becomes bigger when you reduce your path capacity and stuff like that. So that is the case. And then for time varying background capacity is like, as I have said, like if you have a C and then you have a background traffic RBG, then you have a RMCAT flow. That's the bandwidth is C minus RBG. And then basically you could actually retain the constant bottleneck queue depth in terms of delay. So that was the reasoning on adding it. So if you look into the results, and I don't want to really discuss the performance of NADA here, because that's not what we should do here. Please don't do that. Just an example, like how it could look like. So this is how we used to do, like you change the physical capacity of the path. This is how it looks like. And then next slide. So here you see when you introduce the UDP traffic, and you see the figure doesn't look exactly the same, or it should not, because you're competing in the queue. You have you have to push somebody out perhaps. But you can also see like this has some, I mean, I don't know, like how the last part of the results, why it's going up. So I don't know, I cannot explain it. Maybe Xiaoxing can do that. But this is how it looks like.
But yeah, Varun Singh again. So not discussing, but what you see, the delay spike is wider here, right? And that width would depend a lot on the type of UDP traffic you insert. Like, was it small packets or large packets? And because those packets are in the queue, and
Yes.
as you said, like the queue has an interaction right here. So if there are more packets, then your behavior might be different from like if you had smaller, like larger packets there. So.
Well, that was the concern I think I already told, but the working group said like it is fine to discuss. So basically now if we still keep this on, then we basically need to discuss those things, like how do you generate the constant bitrate. Do you have any suggestion for on that? You're a co-author on this draft.
I know, but I'm just wondering, like, if we need to do that now, or do we need to like do it further in the week, like discuss this?
I think we need to run simulations, I mean, to see what is the impact. I mean, other than that, I cannot comment on this one. I mean, I don't want to do a theoretical analysis of this one. Okay. Try to see.
Fair enough. Yeah. But that would just mean that we would have to say that 5.1 point whatever this is.
That
is
just
still
means
taking.
Like eval criteria. We will have another section defining the constant bitrate behavior.
Right.
Okay. Any more question on that? I mean, I don't know. Like as I said, don't judge NADA here. NADA's performance is not important here.
So just so that we don't forget, is whoever's taking note, I think that was an action point for me to like put the behavior of the UDP traffic in the eval criteria. Okay.
Yes. Okay. Next slide. So RMCAT wireless test cases that we are now currently working on. As I already said, we are now reviewing, the authors are reviewing it so that you get a better alignment of this March. So we're planning to submit it before Friday so that you can have a chance to look. Yeah, so another change was like the Wi-Fi test case was restructured because we in the wireless test case that we followed the format that we agreed upon how to describe test cases, and the Wi-Fi test case was actually aligned to follow the same format. And I hope we can submit it by this Friday and you can have a chance to read about it. But I would like to know if anybody has done this Wi-Fi test other than NADA. Stefan, have you? So I can say what I did. I actually had a summer worker this summer, and I wanted him to actually implement this in a real test bed, and it is utterly difficult to implement the Wi-Fi test cases. So the Wi-Fi test case also, I think that should be go into the draft saying like this is a simulation kind of thing. This you need a simulator. I mean, 8 flows, and actually you almost need a bunker actually to retain yourself, not to have interference from other. I think the draft kind of now discusses what is the effect if you have some B and N and mix up these things or these Wi-Fi technologies, but I think that need to be in the draft also. Like for LT test case, we say like this test case is basically for simulator.
Mia Kuliman from the audience. I remember that for the basic test cases, like very early in the process, we decided that because the document was very long from the beginning, so we decided that we take a set of test cases, like 5 or whatever, and say this is the one that have to be run before we can proceed the candidate documents. Should we do this for wireless test cases as well?
Yeah. Because there are 2 things there. In Wi-Fi test cases, I think there are 2 parts. One is like when you only judge the radio part of it, and then you also have a section where you judge the You don't really just the radio part of it. If you say like, if the wired part of the connection, I mean, there in the connection you have a wireless part and a wired part. The wired part, if you overload, how does it behave? But I mean, those need to be, we need to select, we need to pick. I mean, is this really needed? Is this like like for sanity check, or is really required? For LTE test case, with particular side, like we're not talking about the rest of the path, we are only talking about radio. For Wi-Fi test case, it's both radio and the wired. So, and we need to pick perhaps. That might be a good idea.
So for the LTE test cases, there was also a problem that others say they don't have the simulation environment to actually run those test cases.
But,
has this been resolved?
Yes, we have. I think in the draft research, like you can use NS3,
Okay.
and I have actually personally contacted with the NS3, similar to the Lena guys, and they confirm like they actually can run, and actually it's possible following the text. Now they had some comments. They didn't send it in the mailing list. They had some comments like on propagation model, what exactly we mean. I actually updated the draft so that you actually know what propagation model you should really use it there. And I think NS3 NS3 LTE simulator has those, so you can run it.
So then it's a task for the authors to pick the test cases that have to be shown, and then it's a task for the authors of the candidate documents to show that they have run those test cases.
Varun Singh, just curious again, have you run the difference between your own simulation, like the NS3 simulation versus whatever you have? Because the results we've seen in the past were from your simulator, and I'm curious if you've seen any discrepancy in the behavior on the NS3 versus the simulator that you have built yourself.
To answer that one, the one we used on a proprietary solution, the simulator we have, that's much more complex than the model NS3 has. For example, we have in NS3, they actually think the surface is plane. They simulate plane surface. So basically, at some point of your simulation, your user can get out of your cell radius and have no connection. But in our simulator, we do wraparound. So that's what happens in the real life. Like you might get a degraded link, but you don't really get out of cover. So we have a wraparound. So the users say like, if it exits cell 1, it actually pops up in cell 6 or something like that. So those kind of differences is there. I mean, I don't think like there will be much difference on the radio. I mean, if you use different propagation model, of course your simulation results would be different. But whether Scream should work on those propagation cases or not, I mean, somebody has to prove me wrong. Then I think it will work.
So just to have an apple versus like apple to apple comparison, I suppose what you would recommend is that everyone use the NS3 because I think then it would be really hard for us to actually compare Scream to any other proposal just because it was used by a different simulator, or like what would be the way forward?
If you want to do that, you can obviously implement a Scream on NS3. I mean, if somebody else want to do that, they can obviously. I mean, we have open source code, so you just have to hack it to the NS3 simulator. I don't think it's a big
So
deal.
also the idea about picking like this basic test cases, everybody has to show it works, was to say this is safe to start experimentation in the internet. That was not supposed to use as a comparison. And if you pick a more complicated model, which might even reveal more problems, that's okay.
So basically, the draft kind of saying like if you want to see your performance of your algorithm, you can use Lena, you can use NS3, and that should be good enough. But if it is the best simulator in this world, I'm not sure about that.
I'm just curious because what if the NS3 shows something that would work because that's a simplified model and it clearly does not work in your model, and that would be the interesting bit to capture, like do not run this one, right? And
but again, if I don't disclose my proprietary solution, there is no point.
Right, but
the only thing you want me to say, like I can disclose my proprietary, that's not going to happen.
No, I'm just saying that maybe you need to make a recommendation here to say that like these things actually work or are similar. They don't have to be exactly the same, but
That exactly what I cannot do.
Yes,
If
so-
I tell the difference between my proprietary solution and I already did one, but that's basically you will. I mean, it doesn't. I don't think it helps really.
But I mean, that's the case about modeling. Modeling is not covering the reality. You always have to abstract. And if you abstract more in one model, you still have to make sure that you capture the important effects. If you detect that you have not captured the important effects, then your model is wrong and you should improve your model.
So I'm just trying to figure out, like, if the model's wrong, then how do we know the model's wrong? Because he has like he has one that is better.
But
I
that's
mean, like,
different
this is-
discussion, Varun. That's you're asking me like whether I can use my experience to improve the Lena simulator. That's different thing. What I'm saying here, my Lena is good enough.
I think for all those cases, we just
It's
have
good
to
enough
make
to
choices.
make life complex. I mean, obviously you want to. I mean, for radio environment, you want to simulate a complex model, and I think Lena, the NS3 has this model. If it is complex enough with respect to us, perhaps no. But we do use, I mean, in open source, we do use some NS3 simulator. NS3 model is quite good. I mean, I'm not sure
I
pretty
think
good.
I'm just being paranoid right now because I think we've not seen any third party, like apart from you, actually do the wireless test case. So I think maybe we just like delay this discussion until some people could actually implement this. So
Yeah. So next slide. There is no slide, right? Yeah. Yeah, I don't think we need to go.
Okay, cool.
Any more questions? Ken?
Yeah, Ken Kahlberg. When I took a look roughly quickly over the cellular draft, a couple of observations came to mind. And one was there wasn't necessarily any discussion about the potential oscillation, when you're dropping from maybe 4G to 3G and the impact that they may have. So I don't know if that's necessarily out of scope of what you want to consider or not.
I think in these test cases, we don't really actually take that intra-RAT or even inter-RAT handover as an option. So when we're running LTE, all the cells, all the mobiles are in LTE simulation. When you run Wi-Fi, you are in Wi-Fi.
Okay, so yeah.
There is no handover inter-RAT or intra-RAT.
Or dropping fallback or anything.
No.
Okay.
No.
Another thing, and this is maybe too specific with LTE, but one of the things I see is that like with some of the carriers, there's this interest when you have this overload, let's say, where you have the GBR and non-GBR traffic, and when GBR has hit its threshold, they've been configuring these devices to, the towers to be able to extract and take some of the non-GBR traffic, which in a sense would have an effect based on simply the number of users per footprint, and therefore, a lessened number of resources available. And that too wasn't discussed. I don't know, again, if that's maybe out of scope of what you want to consider or not.
Well, I'm aware of those scenarios, but I think for evaluating the condition control algorithms, I mean, that's kind of a serious corner case here.
Okay.
I mean, I don't know, like if you have a strong opinion, but I don't have any strong opinion to adding those kind of scenario. I mean, we can add those things here, but that will be more complex. I mean, you hear the discussion. I mean, even the simplistic view of it's like it's hard to really realize. So I don't think like that's a good idea here to do that.
Okay.
Yeah.
Thank you.
Thank you.
So, Stefan?
Hello, everyone. I'm Stefan from Google. I'm going to present our proposal for RTP header extensions and RTCP messages for RMCAT congestion control. Next slide. So what problem do we want to solve by adding these new feedback messages? So as we see it, we now have basically 3 different congestion control proposals, which all have different proposed feedback formats or RTCP messages. This will make it hard to make these proposals interrupt with each other, but it also means that it will be a lot harder to compare them. For instance, if I would like to implement them all in Chrome and run experiments to see how they compare to each other, that will be hard to do without actually implementing all these different RTCP messages as well. We also see that most of these protocols are split between the sender and the receiver and have logic on both sides. And we have experience from our own proposal that it's kind of hard when you have started to roll it out and run it in the wild, and you want to make an improvement that affects both sides. It will be very difficult to make that change in a synchronous way. Next slide. So the proposal from us is that we think we should standardize on one set of header extensions and RTCP messages that work for all of the algorithms, and that is generic enough so that we have what we need. And to also standardize on running the algorithms or having most of the algorithm logic on one side. So in this case, I'm suggesting the send side and making the other side, the receive side in this case, dumb. So what we're proposing is an RTP header extension that we call the transport wide sequence number, and an RTCP message that basically carries the arrival time of each packet back to the sender. Next slide. So before I go into details on those, I just want to clarify how I'm thinking about this. So where is RMCAT algorithms operating? Typically when we look at RTCP and RTP headers, we see them describing RTP streams. And typically you can have multiple RTP streams being sent between 2 peer connections. And you want all of those streams to be part of the congestion controller. So in my view, I think that the congestion controller is better located at the transport level rather than the stream level. So you typically don't want to have multiple congestion controllers if you have 5 streams going between 2 endpoints, or you have 5 streams in the same peer connection. Because in the end, it's just packets on the wire traveling the same path. Next slide. So that's why we are talking here about a transport-wide sequence number. So it's basically an RTP header extension that introduces a new sequence number that is incremented by 1 for every packet sent on the same transport. So basically between the same 2 pairs. And it can then be used by the sender to identify packets and help it know what packet corresponds to what information in the RTCP message.
Hi, Colin Perkins. So if we are to do this, and I'm not saying that we should, but if we are to do this, I would suggest that a 16-bit sequence number is too small for the whole bundle of streams, given that we have a particular codecs where it's too small just for one codec, let alone a collection of them. So since you have space, you may wish to make this bigger.
Yeah, that's a good point.
Isn't there another header extension for timestamps somewhere that the Google uses for like putting the timestamps on the send timestamp?
Yeah.
Could we add both of them together?
So in this case, I don't think, if I can continue, I think this sequence number can replace the send timestamp. I don't think there's a point in having it with this new setup.
Okay. There's another question, because this is transport wide sequence numbers, and this other word, which is multipath RTP, which tries to split the same video over like media stream. And it'd be interesting to see what the impact is there. So
yeah. All right, next slide. So we are also proposing an RTCP message that goes with this. This is also transport wide in the same sense. So it's basically payload type 205, which I think it's RTPFB. It contains basically, it contains the transport sequence number of all the packets that it has received, and attaches to those sequence numbers the arrival time of those packets as recorded by the receiver. So those all of these are encoded in a fairly simple way. I will describe that shortly. But worth noting here is that we have a base sequence number and a reference time attached to each message.
Yes, I noticed that there's a difference here. This one is PT205, and I think in the previous format you had a sort of identifier number after that. And the reason I'm asking is that shared bottleneck detection will also want to use probably PT205, but the congestion controls need to use it as well. So we need something to identify different types of packets.
I think you can use different FMT parameters to differentiate between them. So if you pick 16, then we're good.
You just put TPD for now, and the INR will figure the magic out.
Okay, thank you.
So I'm wondering what the SSRCs do here.
Actually, also you have to say your name.
Varun Singh. Yeah. So repeating the question, you have transport-wide sequence numbers which go across SSRCs. Will I get concatenation of these for each SSRC, or?
Yeah, no, that's not the plan. Basically, you have to have these SSRCs.
So they're whatever someone picked.
Yeah, one of them.
Consistently throughout the session, then.
Sorry?
Consistently, like once you pick, you don't change it, kind of thing.
Yeah, something like that.
Hi, Colin Perkins. I think this is identifying the fundamental problem with this. Everything in RTP is based around the SSRC, all the feedback, all the streams and so on. And sending feedback over a bunch of SSRCs where you only list one of them doesn't make sense.
No, I can agree with that, but I think that's an artifact of how RTP is designed.
I think you can achieve your goals in a way that's compatible with the way RTP is defined, but I don't think this is the way of doing it. And I also think most of this is already specified on a per stream basis in RTCP XR. And so you're reinventing the wheel in a way that doesn't really fit in with the rest of the protocol.
Yeah, I'm not sure about that, but yeah, we can discuss it.
No, I was just going to say that maybe like we should identify what you want as requirements, and then maybe go to EVTX where people who understand RTP very well would be able to, because I think right now, like looking at this, I don't think we can come to an agreement. Maybe what we really need to know is what information you need, and then figure out like in AVTX how we represent this, and what would be the right like level of doing this.
But to make it clear, the goal I'm trying to achieve here is to be able to feed back to the sender the arrival time of each packet that has been received. Sorry?
We did an RTCP Excel block to do this 10 years ago.
All right.
Okay, Michael Romalo, Cisco Systems. Yes, Stefan, I'm sympathetic to the ability to do congestion control on an aggregate that goes from point A to point B. Sometimes the point B isn't the end client. So my question has to do is, have you thought about this in cases, for example, where I'm simulcasting to a switch? I may be sending the same video stream in 3 different resolutions to a switch, and then the switch is splitting it up and sending it to wherever it's going without transcoding, right? So in that case, I'm wondering what the transport-wide feedback message is. Is it just of the bundle that goes to the switch, in which case it needs to generate its own RTCP, or is it all the way to the end clients? And this gets to the, whether or not it breaks RTP and the AVT core question. So I'm going to ask you, what is your definition of transport-wide for those sorts of cases where not all the entire bundle that you've sent out goes to a given end client? So hopefully I was clear in that. It's kind of a complicated question.
So the way I'm seeing this is that we have a transport between 2 peers, and the other peer could, in this case, be somewhere in the cloud in some network equipment. But in that case, it has to terminate the
RTP session. Okay, and that's okay.
Okay, so next up will be Randall. So Randall,
Thank you.
have the mic.
Randall Jessup, Mozilla. Couple questions. One is how would this transport-wide numbering and hacking work when you have different portions that might have different DSCP values? Would that affect this, or do you split it, or and so forth? Because those would have to be have different congestion contexts. And the other was, I'm not certain whether it makes sense, but maybe in light of some of the other comments about SSRCs being an issue when you're and choosing one of them, might it make any sense to consider, especially in the two-way contexts, any sort of piggybacking in an extension, piggybacking some of this data back at the transport level instead of at the RTCP level, and an extension on the RTP going in the opposite direction. That's it.
Yeah, so the answer for the first question, I have been thinking about the DSCP issue. I think that this is a general problem if we're going to do congestion control between 2 endpoints, and we want to include all of the streams in that estimate or that congestion controller. I think we basically have to be able to identify that there are different DCP markings and run several instances of this. So basically, in that case, the transport, so to say, would be different. The second question was whether we should attach the feedback to RTP packets instead. That's possibly an optimization we could do.
Mia Kuliman from the audience. I probably kind of ask the same question than Michael already asked. But I want to phrase it differently and see if you say yes or no. So transport-wide means that you have some coupled congestion control in there. which might be either one congestion control instance and some scheduling, or it might be different congestion control instances which are coupled, right? Okay, so you assume this is like, it's there and you will use it. Coupled congestion control.
I'm seeing this as something where you have one congestion control instance for all the different RTP streams between two endpoints.
Yeah.
And the congestion controller looks at packets. It doesn't really care about the streams.
Yeah, but you also had this example of that they tried to split video traffic over different paths. And in this case, you have different congestion, and you should actually have different congestion.
Yeah.
Control,
So
right?
we have to identify those cases. And
so you need shared bottleneck detection, and you need coupled congestion control, whatever that means.
yeah, if you want to, I mean, the shared bottleneck detection piece of it is only valid for the case where you have several transports, right? And you don't know if they are taking the same path. And if they do, you want to use one congestion controller. And
you don't know.
Right.
And Jahid Eriksson, I think I was going to tell the same thing as Maria, but Maria already said that. I also think that's a valid issue here, the definition of the transport-wise sequence number. But my next thing is, like, I didn't get the DHCP thing that we're talking about. Are we talking about one single transport having video with different DHCP code point?
I think that was what Randall suggested, yes. And what I'm saying is that then we would basically have to identify that and handle it as two virtually different transports and run two instances of this.
Okay, but that is same thing that when you have couple congestion control, that's like coupling from two different transport connection into one. It's kind of like.
No, not really. I don't want to start talking about combining different packets from different transports. I want to look at a single transport.
So I think your assumptions was single transport, multiple flows, and you have a single congestion controller controlling the.
Yeah.
That's the simplistic view that you have, and you think like everything will be multiplexed on the single port. Yeah.
So it's that specific case.
That specific case. I think that needs to be clear. Like, we are talking about only this case, but I don't think like we can really have an RTCP extension only to describe one particular case. I don't know, like, how do you do that? But yeah, that's my comment. I mean, that needs to be clear. Like, we're talking about a particular case.
Okay.
I was just having a bit of a problem trying to figure out so the received delta is the receive timestamp on two consecutive transport wide sequence numbers.
If I can continue the presentation, I will go into the details of that.
Okay, then I will hold my question.
Harald Aldestrand, attempting to think on my feet here. What we know we have is a sequence of packets arriving at the destination. And the packets, and if in the simple receiver model, it's logical. I haven't talked to Stefan about this before, so I might be completely off base. It's logical that the receiver shouldn't know or care which transport flows this packet belong to, as long as he knows that he's going to report on them in one RTCP message. And therefore, it should be the sender's responsibility to keep track of which packets have gone out under which congestion controller and which packets have gone out with which DHCP markings. So all the logic about either having multiple transport controllers or a single transport controller or multiple DCP points or single DCP points, in this model, I think they belong at the sender and they will not affect this message.
Seconds, I think, Harold.
We have 5 more minutes in total, and you have 2 more slides. Do you want to show them?
Yeah, I think that would be good since there
Yeah.
are questions related to it.
And I cut the line after Karen.
So I think Harold's last comment is a very strong argument in favor of doing this on a per stream basis. So you report back to the sender for the separate streams and let it figure out what to do with them, rather than combining the information from the different streams in the reports and then having the sender uncombine it to figure out which stream it came from. I also, I think, disagree with this comment that it's all just a sequence of packets on a 5-tuple and it can all be treated together, because the congestion decisions are made on a per flow basis by changing the compression for that flow, a per stream basis, by changing the compression for that stream, so that all the decisions which are driving how the adaptation happens work on a per SSRC basis, or a group of SSRCs if it's a layered codec, but not for the whole transport as a whole. So it seems to be combining a bunch of things together for the feedback, which you're then going to need to separate out anyway, in order to do the adaptation, in order to know what you're reporting on, in order to support different diff-serve code points. And the different diff-serve code points issue basically falls back, in the most common case, to audio and video being treated differently. Therefore, it falls back to a per stream basis. So I don't see what you gain by doing this. Plus, I think it's not really compatible with everything else we've done in RTP. So I'm confused what the benefit is.
So as I see it, you try to compute the amount of bandwidth you have available on the link. And the sender will then, based on what number it came up with, decide how much of that bandwidth it wants to spend on stream A, on stream B, on stream C, and it allocates it. And then those streams can configure and control their bit rates.
I agree with all of that, but I don't think total per transport feedback is the right way of achieving that.
All right.
Okay, I'll also just, I mean, this is just a general comment. I mean, one thing, you had two general properties of your proposition. One of them is this coupled congestion control streaming that perhaps will be resolved. I mean, then the other thing I think we have to relate to is that you have this assumption about all congestion controls being sender side only.
Mm-hmm.
And I don't know how, I mean, we have 3 proposals in this working group and one of them is not sender side only. So this idea about that this mechanism would be a generic mechanism for all proposals, I mean, there's some way to go there.
Yeah, so
Not sender side only. I suppose NADA requires for some specific things to be computed at the receiver.
yeah. But the thinking behind this proposal is that if NADA has this information on the send side that we are feeding back, it can do all the computations that it's currently doing on the receive side.
Yeah, yes, I understand that, but that also means that, I mean, that there's some way still for this to be a generic proposal. I mean, at least we would have to bring NADA to agree with that idea.
Yeah.
Okay, next slide, I guess, right?
Yeah, so basically this just explains that we try to encode whether or not a certain packet with a certain sequence number has been received or not, and we try to encode that in a fairly simple way just to reduce the bandwidth slightly. I recommend that you read the draft if you want to know the details there. Next slide. And then we have these receive deltas that you Varun, mentioned. So we basically in each RTCP message have a reference time that is an absolute time value. And the first received packet that we want to ACK with this message refers to that reference time with a delta to it. And the following packets will refer to the previous ACKed received delta, so that you kind of don't have to have absolute timestamps for each packet that you want to ACK. That's basically it.
Yeah, Jörg, just one quick question on the previous slide. This is a different encoding than we have been using elsewhere, or is this the same? You sounded like you came up with something new or something slightly different compared to all the other run length encodings we have been doing in RTCP.
Okay, I'm not sure.
Is it the same or is it something different? That's all I want to know.
Okay, I'm not completely sure if it's the same.
Well, it should be the same because you don't want to have 3 different ways to represent the same stuff, and the same should hold for the deltas.
Agreed.
Good.
So, yeah, so with the deltas, so one thing that I need to make sure is, would the sender need to make a table or keep data about like when it sent the packet so that it could calculate the deltas at its end and then correspond that to the deltas it receives? Because I'm not sure if we like use the RTP timestamps would be sufficient, because I'm not sure what they send.
So what did you mean there? Could you take that again?
Like, for example, you put the transport wide sequence numbers across all flows. Would I, as a sender, need to keep track of what was the send time for each of those flows? Because otherwise these deltas, right. So I think that was one thing that was missing from the whole puzzle, because when you said you don't send them, I was like, okay, you don't need them.
Yeah, so the idea is that if you get feedback about what sequence number has been received and when it was received, you know when you sent it.
Right, so you keep a table of all the, and then once you get the deltas, you remove them and you compare the deltas. Okay, I think that makes sense. And on the other hand, I would say like all this, like the discussion of what we need should be discussed here in this working group. I don't think like discussing the packet formats is like ideal here.
I agree. It's better to focus on what we need.
Right, and I would say that we should move forward with what is needed and like get consensus on that. And once we decide what we want, then go to that appropriate working group to actually decide how we like put it into bits on the wire and that it's that working group's responsibility to make sure that it conforms to whatever RTP wants from that.
So I plan to bring this up at ABTX just to notify people that we are doing this.
Just a really small PASTA, packet sampling research, where it does samples randomly. But recently there's been network calculus, which actually likes curves better, because you actually want to have a batch of packets which are in sequence in order to study how the network reacts to whatever the burst is. It actually comes down to the bursts of packets, and you don't actually want to see the delta between whatever the packets are. You actually want to see how the network reacts to the curve. So rather than delta, you might want to consider some flexibility in terms of how to sample.
All right.
It's just sort of like more research topic.
Yeah.
Say your name, please.
Murad Kutek.
Yeah, if you have any references, I will be happy to.
Network calculus, there's a book written on this.
Yeah, sure.
And what it does the curve. In the curve, what's interesting.
You have to take it offline. Sorry.
Just look it up.
So the first question we need here is if the group is interested to talk about a common format, and that means basically if the proposed candidate solutions would be interested to talk with the others to find a common format. And then as Varun actually already said, like we can try and talk about this format here, or like the content of the format, but at the end we have to go to a different working group to get the standardized. This will not be in this group.
I would, like Varun saying again, I would really say that we just figure out what information is needed and fund the whole discussion on like how we represent that information to another group. It's 8 bits, 16 bits, 12 bits.
Yeah, no, sure. But like my first question is, are you willing to find a common set of information here?
Definitely.
Jahid Erickson. In the scheme draft, we used to have our own message format, but we removed that in the recent one. And rather than we actually described what we need, what are the things we need to actually make a scheme work. And that is exactly a way to support this kind of work. Like when somebody defining some generic feedback message, they can have a look at that paragraph and say like, okay, for each stream this is needed. So all I need to do is to look into this message format and say like, if I can at least derive it. And we have looked into it. I think the packet, it some works, and we're planning to actually do an implementation of it. I mean, we have planned, see like if this is gonna work, the generic feedback message in the OpenWeb RTC, because in OpenWeb RTC currently we use our own feedback message.
Okay, that's good, but I think it's not quite as you said, because even if you say I need this information and the other candidate says I need this information, the information might be very similar, and you might apply changes to both or one of the algorithms to make it the same.
I don't think like the algorithms need to be changed. Is that because we have already designed it? I think the feedback message need to be like cope with the need that we have. So what I am saying, like, well, receive delta here, it works for GCC. I would like to see like if I can retrieve the same information that I need to make scheme works. If it doesn't work, I'll come back and say like it doesn't work for me. And that actually like abolishes the main object of doing this work, because it should work. I don't want to any of this algorithm to go back actually to fit ourselves with a new thing that we are designing. We already designed our algorithm, will not change that one perhaps. That's too much work. That if I, but this is a new thing. I mean, when you are designing a new feedback, that's the way I should work on it. So I'll list all the requirements from GCC, NADA, Scream, and see like if I can really make a generic feedback out of it.
So you're positive to this idea about finding a generic feedback message that every sender will, every receiver will send back, and the receiver does not necessarily need to know what kind of congestion control that the sender is using.
Exactly, that's the point of this.
And that was the question.
Yeah.
So Michael.
Thank you, Michael Romalo again. I'm also empathetic to the timestamping and also the universal or commonality of the RTCP feedback. My issue here is what is meant by transport wide, and I think an assumption on the actual topology that's involved. If you've got a multiplicity of streams all marked with the same diff server code point, all going to the same end client, this can be made workable whether or not it's wise or not.
But that again sounds like some details that we could sort out. So I mean, the generic question was, are you also supporting the idea that we are looking for a generic feedback message that all send algorithms could use?
Yes, but not necessarily defined as this transport-wide concept, because I think
understood.
it has,
Sorry, we have to hurry up. We have one more presentation, so be very quick, please.
Hi, Colin Perkins. I think I would support some requirements analysis to see if a generic feedback is appropriate. This seems to be jumping to a solution without having done the analysis to see whether it's appropriate, and without having done the analysis to see whether the existing mechanisms can solve it. And I think we need to do that requirement step.
Yeah, very good proposal.
So Varun Singh again, quickly. So I'd like to see the requirements, because I think there are already many mechanisms out there for in RTCP XR and AVT which could be reused. They might be heavy and whatever, and that would be like another discussion to have, like if we should use these like 4 independent blocks or like merge them into one, because it makes sense now. But I think first we would need to do the work on finding out what we want, then go and do the analysis on what already exists, and if that's appropriate, and then come back and have this discussion of like if those things are inappropriate because they're either too large or something similar, then come back and do this work. So to
summarize, I think there's a large support to find a generic feedback mechanism, and we need to do some analysis requirement work here first.
Yeah, makes sense.
So final presentation by David.
Good afternoon. This is an update on our shared bottleneck detection mechanism for coupled congestion control. We have a new author, Christian, who's been helping us with a Chromium implementation. I'll skip this one. This is the changes in the revision. The change from 2 to 3 was just I misspelt Christian's name. So, but Based on Christian's work implementing this in Chromium, we've sort of refined the text, improved some of the terminology, and made things a bit simpler for someone. The statistics are designed so that they can be calculated incrementally, but the draft didn't necessarily show you how to do that, so we've added some of that information there. The packet delay variation statistic we used as a base, we've replaced now completely with the mean absolute deviation based one to give the variability estimate, because that is a more robust estimator for what we're looking at. We've outlined what we think would be required for initialization, initial setup messages, and that will depend on what happens if everybody decides to move everything to the sender as well. So, and we've put a step-by-step. Christian was saying that it's a bit hard to work out how the weighting works in calculating some of the statistics. So I put in a step-by-step method on how to calculate the weighting for skew estimate. The other ones are very similar. Okay, thanks. We can skip this one. We envisage at setup, probably within SDP, that the sender would send a message saying that this is SBD version 1. It would like from the receiver a set of statistics, which is extensible, but there are 4 of them which are compulsory, and that it also would like these statistics collected for M, N, F, and T parameters. Okay, the receivers would respond with the subset that they can do. So that's how we propose, which from what I can tell is how SDP goes about things. But the shared bottleneck detection software, the way it's implemented in Chromium at the moment, works on the sender and the receiver and can work on both of them together. So we'll see if all the one-way delays do get fed back to the sender, we may not require all of the messages that we've got. Okay, thank you. Now this is just a quick note on what we've been doing in Chromium. It's not quite finished yet. I was hoping it would be so we could show you some results from it. At the moment, we're using the August version with the Google congestion control version at that time. Things in Chromium change rather rapidly, so we've got to sort of stop it for a while so we can do our work, which means that in this one, Google was doing stuff on the receiver as well as the sender. Okay, we use the inbuilt simulator that is in Chromium, and that was nice for debugging things in general, but it introduced all sorts of artifacts in delay measurements and so on. So after we sort of got things working, then we needed a test bed to progress any further. People have asked about Wi-Fi tests quite a bit. We actually did do a few preliminary ones, and we're still working on that. These are real Wi-Fi, not simulated tests. We found some interesting loss patterns, but at quite low losses, which means that in the SBD algorithm, we only look at losses when they're statistically significant enough to be valuable to us, and at low rates they're not, so the algorithm doesn't use them. And the delay rates, the delay signals that we saw seem to reflect the sort of congestion well enough for us to use for our statistics. Now, we did some initial experiments with 2 flows, and of interest to us there especially is how the congestion controller's reaction to different events is observed in the statistics we're looking at. And what we found, which we're still trying to pin down, is often we had one flow that sort of died away and only sent less than 1 packet per second, which of course means that we don't get enough usable information to be able to determine whether it is sharing a bottleneck or not, though in the case we tested, we knew it was. And we are not sure exactly what's happening there. And that's about the state of what we're doing at the moment. And we're still working on this implementation. And when we get it into a less experimental format, it will be publicly released. What we think remains to finalize the draft. And the main thing there is to define the packet formats for sender and receiver and how they fit in with the other proposals here, and specify exactly what the sender-receiver interaction has to be. Other work we're doing, which I don't think is related directly to the draft, is the paper we're working on, which has a number of different tests and extensions that, including some of the things I've talked about, clustering and other things, and quantitative tests that people have asked for. We've actually mostly done that, and sometime we will present them in the paper. So thank you very much.
So thank you. We unfortunately don't really have time for questions. So you have to take this on a mailing list. But I have to ask this quick question. Like you say, you want to define a packet format here. That's something completely new. That's not in the draft up to now, right?
That's right. Well, in terms of this packet format, it's the RTP type things. We have to send messages, the RT control protocol. We have to send messages, and we want to know where to put them in.
So this was my question. Does it use the, can this work with the standard information that's in RTCP already, or does it need extra information?
We're working with what's, at the moment in our Chromium implementation, we're working with the information that's sent by the Google congestion control packets.
Right.
So
Which
I actually
is a
have the feeling-
timestamp every packet in one-way delay, but we only have it implemented on one side at the moment, so we're not feeding back any information. And that feeding back information, if it is all on the, if the grouping is, if the statistics are collected at the receiver, will be the statistical information, and the grouping will probably be done at the sender. Sure. But that can actually be done either at the sender or the receiver. What we need is the one-way delay measurements for each packet to work on.
So I mean, like, it's your choice, or like, actually it's a working group document, so it's a working group choice. But from my point of view, that's a different document, and that could be like defining the format could be an additional document, except the working group really wants us to have right now. But like, I thought that this document is basically ready to ship, just describing the algorithm as experimental.
Okay.
And then if we actually aim for standard tracks later on, then you can maybe add this part on the header, sender, and receiver formats as well.
Okay then.
And we still don't have time for questions.
Okay.
And so from like last time I talked to you, my understanding was that you want to make one more update with like smaller changes, and then we go for a working group last call here.
Okay.
Instead of defining the packet format, if you in this update could be very clear on what information that you need to have exchanged, then that would be okay.
Okay then.
Yeah.
Okay. So if that's a plan, that works for you?
That works for me, yes.
Perfect. Then thank you for being here. That's the end of our meeting. Thank you for giving a presentation. And thank you to the note takers.